So now, without further ado, it is my pleasure to introduce today's first speaker, Frank Borkin, President of Ipsos's Automotive Client Team. Frank, you have the floor.
Good morning. Thanks, Ellen. Appreciate it. Good afternoon. Good morning. I know we have some people on the West Coast joining as well. So first, you guys will see, I know some of you join us through our webinar series through the rest of the year. I think this is our 5th webinar this year. And I'm really excited about the topic, really excited about the speakers. So I'm not going to take a long part of my part. I do want to kind of give you an idea of the agenda. And so, Jacob, if you can move through this. Go ahead. So if you guys recall, the last 2 or 3 webinars have been focused around electric vehicles, and we're going to kind of continue down that theme. But this month, we're actually going to be focusing on the impact of quality. What do we need to look for? What should we be measuring differently, and so on. And then we're also going to be sharing some benchmarking information. But I also want to point out that for this one, we actually have some guest speakers from both Honda and from Volkswagen, and we're going to be asking them a little bit about their opinion too. So that should be really cool as well. So Jacob, if you want to continue on. To just set things up, and you guys have seen this slide before, but clearly there's just a huge amount of buzz around electric vehicles right now, a lot of discussion, a lot of awareness. Don't really need to go too much into that. But you can see, Jacob, if you go to the next slide, what that's done is created a large amount of interest. So this slide just basically shows in the last 3 years, that the interest has tripled. From now, this is like 36% of people looking for a new vehicle would basically consider buying a battery electric vehicle. So definitely or probably would. And again, before I turn over to Jacob, one more slide from me that I think we just got to level set. I think everybody on the webinar here understands how important quality is. It's always 1 or 2 when you're looking about what are the main reasons people are buying a vehicle. But it's really even more important when you're talking about electric vehicles, because you're talking about people that are going to take a chance on in their minds, a new technology. A lot of people wait to see a couple of years, to make sure that everything's okay. So again, being able to deliver with high quality, paramount, something that I think everybody understands, and we hope to share some findings that we have on some preliminary research we've already done on that topic. So with that, I'm going to turn it over to Jacob, who's going to kind of moderate the rest of the seminar. So Jacob, I'll send it over to you.
Okay. Thank you, Frank. Thanks everyone for joining today. Welcome to all of you. What we wanted to do today was try and look at quality in electric vehicles and the impact on quality as we see the shift toward electric vehicles. And as we all know, in the beginning, the CEO announces that they're going to go with electric vehicles. And of course, the stock prices goes up. And of course, they'd say, hey, by the year 20, something or the other, that they're going to go all electric. And so usually there's a very good response to that. And usually after that, the engineers get involved or the designers get involved with that, and they can do new things with electric vehicles. For example, using skateboard designs, create new kinds of things like the frunk and everything else, new storage, also the 0 to 60 and so on. So the designers and the engineers also get involved, kind of develop new kinds of looking at the new ways to deliver new features to the consumers. The trouble is, of course, at the end of the day, is after the designers and after the engineers and after the manufacturing people get involved and then put the car out, usually at the end of the day, the quality people end up left holding the bag. And so usually the customer complaints come to the quality people, which is many of you, as well as many people that we've worked through over the years. And what we wanted to do was kind of do a failure modes and effects analysis. In other words, things that usually quality people do. And that's just a fancy term of what could be the problems, what are the potential failures for electric vehicles, and what could be their effects, especially so that we can see to get ahead of them. So we did some brainstorming on this and came up with the following that we'd like to share with you and give you some ideas on what could be something that we're seeing. So we did an FMEA, again, just a fancy term for looking at these things. And we came up with a list of them, and we'd like to explore. The list was much bigger, but these are some of them that rose to the surface that you should be aware of and keeping in mind, because they might impact customer complaints on items like quality surveys, but also things that you'll see in social media and other places. So we'll go through each of these lists with some more detail, all the way from fire, all the way to things which are high in severity. And also we'll talk a bit about the potential frequency, the estimated frequency of such items. So the first one we wanted to speak about was obviously the one that's actually the highest profile item, or a fire, a potential fire or conflagration, or uncontrolled combustion, as they like to call it. And what we saw is we've been seeing more and more of this coming up, more and more awareness, consumer awareness of this, and consumer concern. And so even though the severity is very high, we've seen that the frequency is extremely low. But on the other hand, given the profile of this catastrophic failure, it causes a lot of issues, and it becomes a high topic for consumer awareness and consumer discussion. So even though the frequency is very low, we can see this more in the social media. So what we try to do for each of these failure modes is try and give you some idea of what we see as potential remedial actions, potential preventive actions, and then some other considerations that you might want to think about for this failure mode and the others. Obviously, the remedial action would be a battery exchange or a vehicle buyback. But as you know how expensive that tends to be, and we've seen some numbers which are very high in the recent past, going into warranty and everything else. And so what could be done in terms of preventive actions? Obviously, some things that we have seen is multi-weather testing, multi-condition testing, especially abuse testing in terms of accidents or potential issues, monitoring that, trying to see what tests can be done, and also looking at what the social media is and seeing what consumers are complaining about or what their awareness or their concerns are. Some of the other things to be concerned about here, and of course this is a deeply technical area, is there are very high goodwill implications and fallout for most of OEMs to be concerned about. There's also property liability, because if a fire does come out in a garage or something, then we're also not talking just about the car, but liability that comes up there. One thing that we've also noticed is that supplier culpability in this area is a bit difficult to enforce. You've only got a limited number of suppliers, and with such large price tags for any warranty or campaign actions, many of them they're just not able to absorb it. So the OEMs need to discuss this with their suppliers and see what kind of mutual settlement will be done, and this will be best done ahead of time if there are any potential failures from this. Obviously, there are other potential failure modes with the battery, but we haven't seen as many of that in the press. But we're seeing here and there a little bit of indications. For example, one cell of the battery fails, which may not result in a fire, but could result in some more issues relative to the performance, as well as potentially even resulting in a walk-home warranty where the battery just fails. Again, thankfully, we haven't seen so much of that. So the PPH count, or the number of problems, is extremely low, but it's something to be aware of. So that's the first one and the most catastrophic. The second one, we are seeing a lot more. The frequency is higher, but the severity is, let's say, medium on this failure mode. It's basically a DTU, or difficult to understand, difficult to use, and has to do with how much the HMI is used. And over here, the problem is that given Tesla's entrance into this, most consumers are expecting a kind of spaceship when they get into the vehicle. And most of the designers are looking at many electric vehicles like spaceship. They want bigger screens, better screens, a lot more information, and enhanced features all available on the HMI screen. And so they're expecting more of that. And because of that, this becomes a big problem when you want to try and put all the information on the set of screens and present them in the best way to the consumer. So it's a high frequency item. The things that we're seeing as remedial actions, of course, is after the fact is consumer education, software updates. But the best thing that we have seen is that preventive actions need to be a really careful look on what the strategy is on hard buttons for the strategic button versus what we call persistent soft buttons. In other words, where the button is soft and stays on a screen at a particular location. that strategy needs to be carefully done so that important buttons are kept at the same location, even if it's on a soft screen. And we've seen Tesla and other competitors do things like that. We've also seen the need for comprehensive UX, user experience testing, and possibly even a design of experiments or A/B testing when you have a couple of alternatives, designs that can be done and shown to consumers. Careful also competitive assessments, looking at what the competitive competition is doing and best-in-class practices for that. One thing you do need to keep in mind is ancillary conditions, expectations of EV owners on technology, design, screens, and so on. That's one more item. One thing we've seen, another item is range deterioration. And this is not deterioration, or this is not the range that you get when you first get the vehicle or what you signed up for, but we've seen also that after they've bought the vehicle, that consumers are complaining they didn't get the range they were expecting to get. And this is a medium frequency and also medium severity event. And they get pretty annoyed when, for example, they find out that there is a loss in the winter they just don't get, or a loss over time when there's unexpected deterioration due to the frequent DC fast charger or repeated charging to the maximum capacity. So this is something we need to watch out for. I believe that these all things will be things that crop up into the customer surveys that we are seeing now. There's another issue about recharging infrastructure, and I won't get so much into the detail on that, but this will be in the packet that we send out and that will be available. But that's obviously something you need to consider on the infrastructure that's out there. Speaking as a Tesla owner, and I happen to be one, it's actually a very good infrastructure network that's out there. But on the other hand, many of the others don't have as good a network for going to different places. So there will be consumer expectations for cross-network charging and adapters for interoperability between charging systems. Those are the items that will be affecting this area. One other item that is not as frequent and probably not as well considered is tires. We're seeing that given the higher weight, and it's usually about 200 or 300 to 500 kilograms more in terms of weight for the electric vehicles, there is a chance and more likelihood that the tire wear is sped up through time. And not only that, but also due to the instant acceleration torque. So because of that, there's higher wear, and we're seeing more and more of that, consumers starting to complain about that. So one of the things that we'll have to think about is remedial actions like replacement contract considerations for the tires, and more of EV optimized tire designs and material composition here. There are cost implications for consumers, and of course, there will probably be more road noise, so it'll creep up back into other issues because of the higher load capacity tires that are being designed for these EVs. These are things that we're seeing slowly and coming up in the market. One other point is HVAC. One of the things that Casey will point out later is we did a study and we also compare the Tesla versus other electric vehicles, but we're seeing many of these electric vehicles do have a slightly higher number of complaints in the issue of vehicle doesn't cool or doesn't heat up the car fast enough as expected. And I can tell you this also, my wife doesn't get in the Tesla with me because when it's very cold outside, because she says, hey, it just takes too long to heat up and I can't really have it blow hot air on my face as much as I can with my vehicle. And so those are the things that have to do with the blower. And what we're seeing, some of the preventive action is to try and build an auxiliary heat pump or something quickly to heat up the vehicle and give them, the consumer, the way to feel like as if they were in an ICE vehicle, which is what they're comparing it to. One last item that we mentioned here that our study came up with was regenerative braking. This is an issue that's the lack of understanding or acceptance of regen braking is something that's beginning to crop up in the market. We'll cover more, but let me have Chance Parker cover this in more detail in the next section. So actually, let me jump to the next section here. So let me introduce Chance Parker. Chance Parker has worked with J.D. Power for many years, and then just actually this week, this is his first week at Ipsos. So we'll welcome Chance Parker. We're very excited to have him on board. He was actually the person who designed IQS2 and IQS3 and the first appeal at J.D. Power, and was there with a number of studies, and I've known him for many years and quite an expert in the quality area. So thank you very much for joining, Chance. Over to you.
Thanks, Jacob. So as Jacob mentioned, battery EVs represent an interesting technical soup of both opportunity and risk. Frankly, it makes the engineers' eyes light up with the possibilities, but that also carries some potential for reported quality problems with the end consumer. If you don't believe me, you don't have to look any further than the struggles the industry still has implementing high-tech infotainment systems to understand what I mean. So I want to spend a few minutes reviewing the current state with you of regenerative braking executions, the areas of risk, the areas of opportunity. Next slide, Jacob. Next slide, please. Thank you. So I'll be going over 4 main areas. We'll sort of start at the 30,000 foot level and talk about consumers' understanding or lack of understanding about regenerative braking, its benefits, and when and why they should use it. Then we'll start to dig into what the industry is doing. I'll talk about naming conventions, which ones might be helping, which ones might be hurting. Then we'll drill down a little bit into some various executions. We'll go over 5 or 6 specific models and how they have executed and offered different variations on regenerative braking. What are the pluses and minuses of those executions, and where is the potential for reported problems from the end consumer? And then I'll wrap up with our best thinking on what manufacturers can do to increase understanding and adoption of the technologies, and most importantly, decrease that potential for reported problems. So let's talk about the consumer for a second. So I know that, Frank highlighted all of the buzz that we see in the industry about the move to electric vehicles. And there clearly is a ton of buzz. But it's important to remember that we're still really early in the EV game. I mean, it's still, less than 5% of retail sales right now. What that means to a large part is a lot of people that are jumping onto the BEV bandwagon right now are early adopters, and they already have a basic understanding of the concepts that they're getting into. They tend to be a little bit more technically savvy and technically curious than sort of the mainstream consumers, and they're more likely to have a vested interest in understanding things like regenerative braking, how it works, when to use it, when it doesn't work, and why not. Again, we're in the early days of EV sales growth, and as the manufacturers push EVs, the only way they're going to get the growth that they want is to attract the more mainstream consumer, and that brings some quality risks with it. The more mainstream consumer may not be as well versed in the technologies that they are signing up for. They may be much less likely to understand things like regenerative braking and how it works and when to use it, and that is a risk. Next slide, please. Right now, the industry is again in the early days, and you can see that there is plenty of opportunity for confusion. Potential problems aren't just limited to the functionality and physical design that they offer the consumer. Words and names also matter. And if we look across the current model range, there is a wide range of terms and concepts that have the potential to create confusion. Let's start with the concept of regenerative braking itself, kind of the column of words on the left side. Sometimes manufacturers refer to it as regenerative braking, a very technically correct term, but you could question how many people will understand what regenerative really means. Other manufacturers will use terms like efficiency and recuperation. It's important to pick terms that are consumer friendly. I would even argue that the term braking might be problematic for some consumers because, after all, when someone lets off the accelerator pedal and regenerative braking happens, they're not physically braking. They are simply coasting. And that's the kind of confusion that can occur when you're dealing with a non-technical audience. The system's not a lot better with regard to specific words that the manufacturers use to describe the drive mode that they offer. This is sort of what you see on the right side of the page. We see terms like normal and standard. Well, does that mean normal and standard for an electric vehicle, or does that mean normal or standard for an ICE vehicle that they're used to? Similarly with things like high and low and D and L. Those carry some meaning because of how they were used in the ICE world, and they may mean something completely different. in the EV world, and that is an opportunity for confusion. Next slide, please. So let's talk about some current executions and what we might be able to learn from them. I'm going to start with Tesla. This isn't every single model that's out there, but I think it's a good cross-section. So let's start with Tesla. So Tesla, as Jacob mentioned, uses soft keys for pretty much everything, and regenerative braking is no different. They offer a soft key choice under the label regenerative braking, so they are using that very technical term, and they allow the customer to select low or standard. Now, in their case, standard is actually the most aggressive setting for regenerative braking, and low is the most similar to an ICE experience. In addition to a regenerative braking toggle, they also offer a separate switch for what they call stopping mode. They do offer one pedal driving, but in order to get one pedal driving, the customer actually has to select standard on the regen soft key, and then they have to select hold on the stopping mode soft key. The advantages for Tesla are there are only a couple of options to choose from. They have resisted the temptation of offering a plethora of modes, and they do offer one pedal driving. The downside for Tesla is that the interaction between regenerative braking modes and stopping modes is pretty unclear if you don't really understand what it means. And again, standard may not be the best term for regen or decel maximum setting. The other thing that's interesting about Tesla is they have incorporated only the electric motor into the regenerative braking functionality, so you get a different level of deceleration depending on the charge of the battery, and sometimes in extreme cold conditions, that inconsistency is a risk. The final thing I will say about Tesla is because they use only soft keys, it's easy for them to update and change what they offer with, the flip of a switch, if you will. And they seem to be doing that because in their newest models in the showroom, there is no longer an option for low or standard. It seems that standard one pedal braking is now the de facto standard default mode in the new Teslas. We'll have to see how that plays out. Next, I want to talk about the Taycan. It is interesting in that it offers a blend of regenerative braking using the motor and traditional friction braking. They have only a couple of options for selecting modes, a hard key and a soft key. They're redundant, one's on the steering wheel, one's in the screen. And they only offer a couple of modes. The beauty of the Porsche system is the consumer doesn't have to learn any new techniques at all. They just simply step on the brake pedal, and behind the scenes, the computer decides whether it should be regen braking or friction braking or a mix of both. They also use the term recuperation, which I think might be a little more consumer friendly than regenerative. They do have some potential confusion around their modes, and their displays aren't great. Moving on to the Mach-E, they also offer an interesting solution in that they have really a simplest approach, and they have very explicitly not focused on the concept of regenerative braking. They give you three soft keys to select, or a soft key to select one of three drive modes. Completely separately from that, they give you a soft key to select one pedal driving. It's very simple. It's very black and white. You don't have to worry about any confusing terms. It's an easy selection for one pedal driving. They do, though, suffer from a bit of confusion about the one pedal driving experience can be a little bit different depending on which drive mode you're in. Consumers may not understand why that is. And they do have minimal displays of what mode you're in and what you're gaining by using regenerative braking or one pedal driving. Next slide, please. Some of the other executions that are out there that we think, frankly, are a bit more problematic from a quality exposure include the Kona, which uses steering wheel paddles to allow you to select up to 4 modes, up and down, using the left and right paddles, coupled with a completely separate smart regeneration mode. So while it's theoretically easy to select modes with those paddles, it is very unclear what happens when you have smart regen versus one of the 4 modes. The 4 modes are just labeled 0 to 4 or 0 to 3. What does that mean? And then they also have kind of a hidden function that you can hold the left pedal and kind of get a momentary brake pedal effect by activating max regen. That's not very intuitive and it's not very easy to use, especially if you're turning. The bolt is another execution that uses steering wheel paddles. In this case, they only have one. And again, the issue with that is you are trying to teach someone a completely new and unexpected behavior for braking using a paddle when they're just simply used to using the brake. It's unexpected. It's difficult if you're turning. It's just, we don't think of best practice. And then finally, the Nissan Leaf, they have something that's interesting. They have a dedicated e-pedal button, which activates one pedal driving, which is very simple. But it is confusing in that you have this interplay between different drive modes that you access with the shift knob. What's the interaction between the one pedal drive mode labeled e-pedal versus another pedal that gives, or another button that gives you eco mode? It's just a little bit confusing. So again, that's kind of a quick review of what we've seen in the industry. I'll wrap it up with sort of our best thinking on what manufacturers need to do to deal with this complexity and the potential for problems as people don't understand how to use it or think it's not working correctly. One, only offer a small number of modes. Resist the urge on modes. I mean, again, it is an engineer's dream, the amount of control that they have with electric vehicles and the amount of modes that they can offer. Don't do it. 2, maybe 3, make sure one of those modes mimics ICE behavior and make sure one of those modes is one pedal driving. Second, don't force the consumer to learn new ways to drive. They know how to use a brake pedal. They know how to use an accelerator pedal. Use those. Number 3, as I mentioned, avoid technical terms whenever possible. Use terms that are easy to understand. Don't try to give an engineering lesson to the consumer. And also be conscious of what you're showing them in your display. Like if they're going to use regen braking functionality, give them feedback on what they're gaining in a meaningful way. Tell them how much range they're gaining. Don't focus on the percent of the battery that's charged or the kilowatts they've gained or things like that. And finally, as I mentioned, in use in the Taycan and the Mach-E, use a blend of regen and friction braking, because this is really the only way that the manufacturer can make sure that the vehicle behaves consistently in all conditions. You just don't want to have the vehicle do something unexpected, or perhaps worse, not do something that is expected. Of course, you have to make sure that you do a good job of blending those technologies. But if you do that, you can give an experience that we think will be simpler for the consumer to adapt to, adopt, and understand. And with that, I'll turn it back over to Jacob.
Thank you very much, Chance. Actually, we are very excited about the next section. We're very excited to have 2 experts from the industry join us. These are one from Volkswagen and one from Honda. Please join me in welcoming Atai Tanuku. Let me just put that, yeah, who is responsible for quality at Volkswagen Quality Operations here. Thank you very much for joining us. And also Michael Maston, who's responsible for quality as the principal engineer down in Marysville for Honda R&D Americas. Thank you very much, guys, for joining us.
Thank you for having us, Jacob.
Thanks for having us.
So what I thought we'd do is just do a quick moderated session, maybe ask you some questions and hear your thoughts on a couple of questions that we've had from a couple of OEMs and we've put together for you in this session. So maybe I can start with Atai. Atai, I'm just wondering, in terms of impact on quality, impact on automotive quality, what do you feel is changing in terms of the design process when it comes to meeting consumer demands for electric vehicles these days?
Well, let's maybe first start. We as Volkswagen started launching our first vehicle here in the market with ID.4. So we're new to the game in the US market. We have our first vehicle out, and I had the chance to drive it myself, and I have to say that I really enjoyed the drivability of the car from a customer perspective. And I didn't really see a big difference between an ICE or an electric vehicle. So that's what I really liked about the car. What I'm still trying to get used to is all the infotainment systems, the electronics, the usability aspect of the cars. So from a customer perspective, that aspect is a little bit, it needs some training. You need to learn these kind of things if you're not familiar with them. But in general, it gave me also a good feeling, okay, where do we want to go as a brand? And I'm responsible for customer satisfaction in the quality organization. So we've been working with the ID4, bringing it to the market, several years ago. We started at the very early design phase, and the focus has changed between IC and EV because we're not really looking into the mechanics that much. We don't look into classic components in the vehicle as much on how to develop those, because everything is new now. And when things are new, you're bringing other departments in, you're collaborating more effectively with other teams that you haven't maybe worked with during the design phase. And we start now also much earlier to bring those customer requirements into the vehicle and evaluate those, do clinics with customers, do pilots and get their feedback, and then revamp our strategy when we have to. So that's definitely a learning experience for us right now. It has changed. And what we also see with our first car here is the complaints that we get from our customers has also shifted. We see now an increase in infotainment and software development problems. So that's what customers are complaining more about than they used to, talk about brake noise or powertrain issues. They don't complain about those anymore. So that's something that our focus is now, taking the biggest part of. And what we also see is when we develop these software solutions that are necessary, how do we bring them into the vehicle? Now, these are the things that we think of. We don't want to bring the customer every time into a dealership when there is a software update. You want to ultimately go to that point where you have, what we have with Apple, for instance, right? You get an update and you do it within a few minutes, an hour, do it overnight when you sleep. So that's basically where we want to go with this, and make it also convenient for the customer. Another difference that we're also seeing between all these new technologies that are thrown into an electric vehicle is, for instance, Apple CarPlay. It's not just an EV thing, but customers are more in tune with those technologies, and they expect the best of it. So when there are problems with Apple CarPlay or Android Auto, it's always a challenge to identify the specific root cause. Is it the car manufacturer that is at fault when there is a connection issue, or is it the phone manufacturer? So that's tricky to figure that out quickly and then provide a solution. The same is true for instance, for charging. When you charge your vehicle, is it the car that when there is an issue with the charging process, or is it the charging station? Is it that we need to talk to the charging station manufacturer? So it's very, very interesting, and it has changed and developed over the last 2 years significantly, the way we do our business and the way we look at things. And we're still learning. There's still plenty to learn, and but it's exciting times for us for sure.
Thank you. Thanks, Tadej. I'm sure many of the people on the call will resound with what you're saying, that they're changing expectations. Michael, just a question for you. What specific quality barriers do you feel that they have to overcome for ICE owners to buy electric vehicles in terms of quality, and what's on their mind when they buy the vehicle?
Yeah, thanks, Jacob. Thanks for having me. So, for barriers to overcome, I think for us, as an OEM, it's more of a perceived metric. I think customers have trust issues with EVs. I think they're very confused about the direction. They can't really see it. They hear a lot about PHEV, BEV, MHEVs, but they really don't know what the difference is. And I think Chance and yourself, that you touched on, some of that terminology during the presentation. So they know and they hear about a lot of it, but they really haven't driven one of these vehicles. They know it looks like a normal car from the outside, and they also know that it has to be charged. So they have a level of untrust, like when it comes to safety, durability, reliability, and of course, range. And so for Honda, and I think like the rest of the industry, the adoption of the EV, it's going to be a transformation. It's going to take some time, and over that time, the OEMs that can build the trust and give exposure to the EV and give that good experience, that's really going to be what wins over customers and alleviates any of the perceived quality concerns they will have. Because in a lot of ways, it operates like a normal car, but customers have all these issues in their mind that they need to overcome, and some of them are from the vehicle. But finally, the more they get comfortable with it, the more relieved they're going to be about owning an electric vehicle.
Thank you. I think so, yes. Michael, one of the points that Atai just also made was about HMI. In your point, do you also feel that have EVs exacerbated the problems with HMI? And if so, how much and what can be done about it?
Yeah, I was shaking my head a lot when Ty was giving his answer, because I think in a lot of ways, right, the mechanical aspects of the vehicle have really been improving, I think, across the industry. So you're less focused on those and you're more focused on the technology. And I think from a consumer viewpoint, this has been happening with the proliferation of smartphones. The technology has really has gotten its way into consumers. If it's in their hand, it's in their house, it's in their job. So of course they expect and they want to see that same level feature set in their car. So when that doesn't necessarily happen or doesn't match, then we can sense a lot of their frustration. We know they're not necessarily happy with it. So for example, like with navigation, you can see OEMs offer a lot of solutions, right? We have the onboard solutions. We have the offboard when we have CarPlay and Android Auto. We do have a combination of them in some cases. But for consumers, a lot of times they don't really care about that. They don't even recognize it to a certain extent. They just know they want it to work the way they want it to work, or the way they've been used to having it in their phone. And when we don't match that, then we get, that's where we get these complaints, or we get this frustration. And so, when we match and when we can deliver seamlessly those kind of things and or exceed them or delight the customer, that's where you'll see a lot of these HMI, these technology things. That's when they just, they become, again, people don't even think about it anymore. They just become very accepting.
Okay. Thank you. Thanks, Michael. So back to you, Atai, one more question. Do you see any changing consumer expectations in terms of things that EVs do well in? For example, the transmission, the smooth transmission, and the pickup and the acceleration. Now that EVs are hopefully getting more prominent over time, will that have a changing impact on the consumer expectations for ICE vehicles across the fleet? Any thoughts on that?
Yeah, I think the expectation of acceleration is there already, right? So when you come to a stoplight and you look at the car next to you and you see it's an EV, with all that torque, that instant torque that he's gonna get, you'll not be able to catch up with it, right? So you already have that kind of mindset that EVs are accelerating fast. It's the way the battery is usually in the vehicle is at the lower part of the vehicle. The handling is very smooth around cornering, and it drives just fantastic. So I think the more people get familiar and have the chance to drive EVs, and the more they feel, and it feels like a normal ICE vehicle, but just better. That's what you're getting today. I think the more people will transition to EV vehicles. That's where the future is going. The challenge I'm seeing right now is, and a lot of OEMs are going that direction with pickup trucks. How are they going to match the perception? Change a pickup driver that drives a V8 to an electric vehicle pickup. And how is that transition going to work? That's going to be interesting. There's a lot of competition going on right now. in the automotive industry. I think time will show, right?
Thank you. Thank you. I'm sure time will show. Any other last comments, Michael?
No, just thank you very much.
Thank you, Ty. Thank you both very much. I really appreciate your coming on, and we welcome to you to stay on and be a part of our session. Thank you.
Thank you, Chip.
Yeah. Moving to our last section, and hopefully on time, what we wanted to do was, you may know that, many of you on the call may know that Ipsos is actually the largest tracking supplier of tracking quality data in the world. And many of our clients actually ask us, so what about Tesla? Where does it fit in? And how do you compare to that? So what we did was a special study on Tesla. And what we'd like to do actually is walk through some of the results on that. And Casey Gino, who's part of our group and has been working with Ipsos for quite some time and responsible for some of our tracking studies, did a focus group, did a benchmarking study on the Tesla, and would like her to share some of the results that she found. Casey?
Sure. Thanks, Jacob. So as Jacob mentioned, I'm excited to share with you today some of the key findings from a special study that Ipsos did on a couple of Tesla vehicles. We'll be looking at the data, deep diving the data, and comparing it to some other EV vehicles in the industry, as well as some ICE vehicles. But before we jump into the data, I'd like to just give you a quick background on this study. So the study was fielded earlier this year in May. This study was on Tesla Model 3 and Model Y 2020 model year vehicles in the US, and it was done at 12 months in service. So we used our Ipsos quality feedback system, or what we like to call our QFS questionnaire. And this is a checkbox survey. So for those of you on the call that might not be as familiar with what that means, just a quick description. Basically, we're asking people to identify what problems that they have with their vehicle. So we ask them at a high level, is your problem within interior, exterior, infotainment? And then we dig deeper. What specific problems are they having? And then finally, we ask them, after they've identified those problems, to provide some diagnostic information on those. So with that, I will jump into the data and share some key findings on what we saw. So we'll start at the high level, and then we will dig deeper into the data and look at what the drivers of some of these numbers are. So you'll see here we have the Model Y and the Model 3, and we're comparing that to an EV average and an ICE average. And again, just kind of to lay the land, so in the worlds of problems per 100, higher numbers are worse and lower numbers are better. So, you obviously want lower problems per 100 vehicles. So looking at the Y in the 3, kind of compared to the EV average, you can see that both models perform very well compared to other EVs in the industry. The Model 3 also is on par with other ICE vehicles in the industry, with the Model Y a bit higher. But probably more interesting to a lot of you is what's driving these numbers, and what are the high areas for Tesla? Where do they do well? Where do they not do well? Where should we benchmark Tesla? What are some of their areas of weakness compared to other EVs and ICE vehicles in the industry? So with that, we will look at the higher problem areas, and then I'm going to highlight some key areas that are noteworthy, and then we will deep dive those areas even further. So starting with exterior, I think this is definitely something to point out for Tesla. So you can see here in the top row, Tesla has significantly more exterior problems, if you look down the two Tesla columns, than any other problem area. They're seeing a lot of, and maybe this isn't such a surprise to some of you on the call, but they're seeing a lot of manufacturing defect issues that are showing up here in this exterior problem bucket, and we'll take a look at what exactly those are in another couple of slides. But even if you look across compared to the EV average, Tesla has a lot of exterior problems. The EV and the ICE averages, they do as well, but less than half of what Tesla's experiencing. Again, now looking at audio entertainment navigation, this is kind of on the opposite side of things. This is an area where Tesla does really well. You've heard HMI talked about quite a bit already so far in this webinar, and Tesla's really setting the stage, setting the benchmark for audio entertainment navigation. This is something they've done really well, and consumers really appreciate. They find it easy to use, and they really like it. Conversely, if you look at that EV average at 78, that really stands out. So you can see, how that Tesla's doing really well here, and we'll get into a little more detail on that as well. Next is I want to point out HVAC. So while this might not be, Tesla's highest problem area by any means, I think the point here is if we're looking across at the ICE average, you can see that, especially for the Y, it's more than double. And that speaks to, again, what Jacob was talking about earlier in the presentation, the fact that consumers, want the vehicle to heat up, faster, get a little hotter, and same on the reverse for the air conditioning. And then finally, another positive for Tesla is in the electric motor battery. Again, an area that, they've just performed really well, especially if you're looking at them compared to the EVs, other EVs in the industry. And we'll talk a little bit more about charging and range and things like that when we deep dive this. So we'll go back up to exterior. I know, this is quite a few numbers on the page, but I'll hit the highlights here. So this is, looking at what are those exterior problems that are contributing to the high numbers that we're seeing for Tesla. And one thing I really want to point out is that, if we look across all problem categories, all the problems, and we rank them and we look at the top 5, most of the time for a lot of vehicles, we tend to see things, it's rare that we don't see some type of audio entertainment navigation problem in the top 5, right? Usually it's audio controls difficult to use, or a Bluetooth connectivity issue. But for Tesla, all 5 of their top problems for both the Y and the 3 come from the exterior problem group. I mean, look at the top 1, body panels, gaps, poor fit or misaligned. We have 16.8 problems per 100 for the Model Y. That's huge. And then looking down, we have excessive wind and road noise. I'd like to point out those as well. Again, those are top problems, not just for Tesla, but if you look across the EV average and the ICE average as well, you'll note those numbers are high, but just not quite as high as they are for Tesla. And in fact, on the next slide, we're going to deep dive into a little bit into the wind noise and look at that specifically for the Model Y. I'll share some diagnostics about that might help shed some light on this. So if we go to the next slide, you'll see, so again, once a consumer or customer indicates that they have a problem with their vehicle, we follow up with some questions to find out more about that problem, and those questions are specific to the problem they reported. So like in this case, with excessive wind noise, we asked them what speed are they traveling at, and the Model Y customers reported that it's generally at higher speeds, maybe not so unexpected. But then, we find that it's the front side door, window mirror, or the rear side door, both with the window closed and as well as the windshield where the wind noise is most likely occurring. But the one thing I really want to point out and focus on this slide is from the consumer comment. So we also, after we ask them the diagnostic questions, we also give them the opportunity to leave a verbatim comment. And here, what you'll see is we pulled a couple of comments, but we saw many more like this, where they reference and basically they attribute that wind noise to the lack of engine noise, the fact that there isn't an engine and they're not hearing that engine noise. Is this true or not? It's hard to say, right? Some of it may be true, especially city driving. When you're on the freeway, maybe not. Maybe it's some of Tesla's manufacturing and quality issues that might be contributing to this as well. But I guess the point is that the customer, they see it as the lack of engine noise. So moving on to audio entertainment navigation, and just pointing out, a few key things here. Again, Tesla is just pointing out how well they're doing here, and how they're basically setting the expectations for what HMI needs to be in vehicles. Their top problem, hands-free communication, connectivity issues. I have a diagnostic slide on that as well. That's their top problem in this area, and it is high for the EV average and ICE average as well, and even higher than Tesla. But as you start to look down the list, I've only pulled out a few of these, but you could, certainly call out others as well. Front audio controls, again, one that we generally see, a lot of times see higher PPH on, right around 1 PPH for Tesla, the EV average at 5.2. Same with the in-vehicle apps and application issues, less than less than 1 PPH for Tesla, 3.5 for the EV average. So, definitely Tesla's HMI system is something to keep an eye on, to benchmark, and to look at. And then, as I mentioned, the next slide, we have a deep dive or diagnostics on the connectivity issue. So, something that's happening for Tesla owners, occasionally, not, intermittently. Most of the time we find that people probably are just using the one phone in their vehicles. They probably haven't tested other phones. But again, the consumer comments tell us, and again, that one of the issue that they're experiencing a lot is when they leave their vehicle, they come back and their phone's it's not connecting automatically, and they're having to manually do that. Again, at 2.6 or 3.3 pph, this is something certainly that for Tesla to keep an eye on. But with the EV average at 6.8, I think we can still say that Tesla's again hit a home run with their HMI system. And then on the next slide, we will take a look at HVAC. So here, again, the top two problems here are, and like I mentioned before, it's not that Tesla is performing extremely poorly in this area by any means. I think the key point here is that when you compare to ICE vehicles, the challenge is going to be, that consumers want, when the heat comes on or the air conditioning comes on, they want it to work. They want it to heat up quickly or cool down quickly, and they're not seeing that necessarily in the electric vehicles, as shown by the problems per 100 here for the EV average, the Tesla models, being about double or even more than the ICE average. And finally, sharing a bit of data with you on the electric motor battery. I mentioned before, again, an area where Tesla's done well. They do obviously have some of the highest ranges, if not the highest, in the industry. So we don't really see too many consumers complaining about the range here. Whereas if you look at the EV average at 4.6, obviously there's, people have concerns with the range, whereas Tesla doesn't. They don't see that same level of concern. And the other thing being the charging system at 1 or lower pph, consumers, they feel more comfortable. They've got the Tesla superchargers, the network, they feel more comfortable with it. I think, Jacob alluded to that a bit in his section as well. But higher concerns with other EVs across the industry at 4.7 with the charging system and the infrastructure and things like that. So, just like I said, hitting a few of the highlights today. But if I had to sum it up, I think what I would say is Tesla certainly has its areas of weakness, namely exterior and manufacturing and defects issues, but electric vehicles are being designed and developed, certainly benchmarking audio entertainment navigation, looking at their electric motor battery, the charging capabilities and things like that. That's where their strengths are, and definitely worth benchmarking them. So thank you, and certainly if anybody would like to know more about this data or hear more about it, we'd be happy to discuss it with you. So with that, I'll hand it back over to Frank.
Thanks, Casey. Great job. And before I forget, I want to make sure I thank both Ty and Michael for joining on this. Great insight. Really appreciate the time. Also appreciate the time that you guys have spent with us, an hour. Hopefully you guys have picked up maybe some new ideas on how to deal with quality in the electric vehicle space. If you do, there was a couple questions that I can answer really quickly. One is, can you get a copy of the presentation? Absolutely. As it may be, again, our normal process is for those who registered, and we basically send a copy of the deck or a link to the deck. But also there's sometimes where maybe somebody didn't enter in the exact right email. So if you don't hear from us, maybe reach out, let us know, and we'll make sure we get you a copy. Last thing I wanted to touch on was next web is going to focus on mobility. So it's very different in the sense that we not only talk about the vehicles, but we're going to talk about shared mobility, public transportation, a lot of change because of COVID. And I think a lot of people are wondering, are we getting back to normal? Are we doing something, are we seeing different trends and things like that? So that will be happening November 2nd. So I wanted to make sure I invited everybody. And that's it. So again, thank you guys very much for your time. Appreciate it.
All right, thank you.
Thank you. Thank you, Frank. And thank you to all our presenters for today's informative webinar, including our special guests. Thank you, everyone, for joining us. Do be on a lookout for the email that Frank is talking about with a link to today's recorded presentation. Of course, we always welcome the opportunity to speak with you directly, so please feel free to reach out. That now concludes today's webinar. Have a wonderful day, everyone.